Good morning, students. So, today we are going to see our next chapter, that is chapter number 9, Force and Laws of Motion. I know there are a few topics uh, in the last chapter that we have not done, but recently your new syllabus came, and those topics will not be included in your examination. So, I guess that's we don't need to study about that, but we'll concentrate on the syllabus as per given by Gujarat government. So we'll go with our next chapter, that is chapter 9, Force and Laws of Motion. Now, in the previous chapter, we described the motion of an object along a straight line in the terms of its position, velocity, acceleration. We saw that such a motion can be uniform or non-uniform. We have not yet discovered what causes the motion. Why does the speed of an object change with time? Do all motion require a cause? If so, what is the nature of this cause? In this chapter, we shall make an attempt to quench all such curiosities. Now, last chapter mainly આપણે જે study કર્યું છે that is related to motion. Yes, we have seen different terms, that was one, position, velocity, acceleration, and we saw that there were two types of motion mainly. One was uniform, other was non-uniform motion. Yes, in uniform motion, equal interval સાથે equal distance cover કરે છે, whereas in non-uniform motion unequal distances in equal interval of times. Okay, but why does this motion happens, or why does the speed changes with respect to time? And if all motions happen, then do they require a cause? Is there any reason why all this motion is going on? So for that, we'll see this chapter and we'll try to find out all such things. Now, for many centuries, the problem of motion and its causes has puzzled scientists, philosophers. A ball on the ground, when given a small hit, does not move forever. Such observations suggest that rest is the natural state of an object. This remained the belief until Galilei and Isaac Newton developed an entirely different approach to understand the motion. Okay, for many centuries, એવું believe કરવામાં આવતું for many centuries that the natural motion for any object is at rest. In short, જ્યાર સુધી તમે કોઈ પણ વસ્તુને હલાવો નહીં, if you don't push anything, that thing won't come into motion. Yes, so they were thinking that okay, um, maybe the rest is the natural state of an object, but that was changed when Galileo and Isaac Newton have explained their approach towards the motion. Now, yes, in our everyday life, we observe that some effort is required to put a stationary object into motion or to stop a moving object. We ordinarily experience this as a muscular effort and say that we must push or hit or pull on an object to change its states of motion. The concept of force is based on this push, hit, or pull. Okay, mainly. So, for simple example, if you want anything to come into motion, or you want to change motion, means anything that changes its place from one point to other. Okay, suppose on your table there is a book which is kept. If you want to move that, you need to put some effort, muscular effort. That means તમારે એ વસ્તુને muscular effort થી push કરવું પડે, અથવા or you have to pull. Yes, but you have to force some effort. Yes. Now let us ponder a force, ponder about a force. What is it? In fact, no one has seen, tasted, or felt a force. However, we always see or feel the effect of a force. It can only be explained by describing what happens when a force is applied to the object. Pushing, hitting, and pulling of objects are all ways of bringing objects in motion. They move because we make a force act on it. Yes, તમે જેવી રીતનું force કોઈ પણ object ઉપર લગાડો છો તો તેના લીધે એ એવી રીતે જ મૂવ થાય છે. Yes, so the way you push or pull any object, or in whichever direction you apply the force, the body or the object would move towards that side. Yes. From your studies in earlier class, you are also familiar with the fact that a force can be used to change the magnitude of velocity of an object, that is to make the object move faster or slower. Yes. For example, if you are playing cricket, yes, you hit the ball with the bat. હવે તમે જો વધારે સ્પીડથી બોલને હિટ કરશો, so it will go with much more speed and much more distance. Now if you defend the ball or તમે ખાલી બોલને સ્ટોપ કરશો તો એની સ્પીડ ઓછી થશે પ્લસ એ એટલું બધું ડિસ્ટન્સ કવર નહીં કરે. Yes, so that is dependent on the power what you generate on the object to change its direction of motion. Yes, we know that the force can change the size and shape of the object. You see here they have given the example. This is a spring. Now if you apply the force, you can see it starts to extend. Yes, the same way there is this sponge ball. Yes, rubber ball છે એને જો. So when you push it, its size decreases. Yes, so applying the force, you can either increase or decrease the size, as well as you can allow કે that object કયા directionમાં તમારે move કરાવવું છે. Now, now related to that, we are going to see our next topic, that is balanced and unbalanced force. Okay, so our topic is balanced and unbalanced forces. Figure 9.3 shows a wooden block on the horizontal table. Two strings X and Y are tied at the two opposite faces of the block as shown. If we apply force by pulling string X, the block begins to move towards the right. Similarly, if we pull the string Y, it will start moving to the left. But if the block is pulled from both the sides with equal force, the block will not move. Such forces are called balanced force and do not change the state of rest or of motion of an object. Now, we example શું આપ્યું છે તમને, that you see this figure. Yes, there is this wooden block kept in between. There are two strings, one is X, another one is at the right, and another one is a Y. Yes, if I pull X string, so wooden block will move towards that. The similar way, if you pull Y string, it will move towards Y direction. But what if you pull both the strings together and with equal forces? So the object will not change its states, it will remain the same position. So this type of force are known as balanced force. Balanced force means કે ભાઈ એ ઓબ્જેક્ટ ઉપર ફોર્સ બધી જગ્યાથી ઇક્વલ લાગે છે જેના લીધે એનું જે સ્ટેટ છે, સ્ટેટ ઓફ મોશન છે, સ્ટેટ ઓફ રેસ્ટ છે, એ ચેન્જ થતું જ નથી. દેટ મીન્સ એની પોઝિશન હંમેશા સેમ જ રહે છે because force is applied equal from all the sides. Now let us consider a situation in which two opposite forces of different magnitudes pull the block. In this case, the block would begin to move the direction of a greater force. Thus, two forces are not balanced, and the unbalanced force acts in the direction the block moves. This suggests an unbalanced force acting on the object to bring its motion. Okay. Now you know what is balanced force. Now unbalanced force. Unbalanced force means હવે અહીંયા બે string છે X અને Y. If I allow X to pull by one boy and Y by another, yes, now the boy who has more strength, so the block will move towards that side. Suppose X પાસે જે boy ઊભો છે એના પાસે force વધારે છે એના હાથમાં, or he has more strength, so the block will move towards X side. Yes, so this type of forces are called unbalanced force. That means unbalanced force માં જે સાઈડ force વધારે હશે, object will move towards that side. This suggests that unbalanced force acting on object and brings it motion. Yes. So the main difference between balanced and unbalanced force, you can know by this, that balanced force માં object એની જગ્યાથી મૂવ થતું નથી, બટ અનબેલેન્સ ફોર્સમાં એની જગ્યાથી મૂવ થાય છે. In balanced force, forces from all the sides will be equal, whereas in unbalanced force, that would not be the same. No. Box with a small force. Okay. What happens when some children try to push on a rough floor? If they push the box with a small force, the box does not move because the friction acting in the direction opposite to the force. This friction force arises between two surfaces in contact. Friction force એટલે જે એવો ફોર્સ જે તમને આગળ મૂવ થવાથી સ્ટોપ કરે. યસ, સપોઝ એક બોક્સ છે, એને તમારે પુશ કરવું છે, so you have to apply such force, એક અમાઉન્ટમાં તમારે ફોર્સ અપ્લાય કરવું પડે સો દેટ ઈ મૂવ કરે. ઇફ યુ અપ્લાય લેસ ફોર્સ, જે ફ્રિક્શન ફોર્સ હશે, તમે એ વસ્તુને બ્રેક નહીં કરી શકો અને ઓબ્જેક્ટ એની જગ્યાથી હલશે નહીં. Yes, so you have to apply more force. Now, in this case, between the bottom of the box and the floor surface, it balances pushing force and therefore box does not move. In figure 9.4b, the children push the box harder, but the box still does not move. This is because friction force still balances the pushing force. If the children push the box harder, the pushing force becomes bigger than the friction force and there is an unbalanced force, so the box starts to move. Okay, so આ કેસમાં બે ફોર્સીસ કયા કયા છે? એક તો જે અપ્લાય કરે છે ચિલ્ડ્રન, એન્ડ સેકન્ડ ઇઝ ફ્રિક્શન ફોર્સ. હવે ફ્રિક્શન ફોર્સ વધારે છે તો બોક્સ મૂવ નહીં થાય. Now if you push that box harder, when the value of your force is become higher than the friction force, then only the object will start to move. What happens when we ride a bicycle? When we stop pedaling, the bicycle begins to slow down. This is again because of the friction force. Now, in order to keep bicycle moving, we have to pedal again. It does appear that object can maintain its motion under continuous application of unbalanced forces. So, ત્યાર સુધી unbalanced force હશે કોઈ પણ objectમાં, ત્યાર સુધી એ object move કરશે. An object moves with uniform velocity when the forces acting on the object are balanced and there is no external force on it. Okay, so this is all related to your first law of motion. Okay, we'll see this other thing in our next module. Okay, so for today this much is enough. Thank you, students.